Uh, Tonight I will give a tutorial about the AIBench. It will about 8 hours. So currently is 10 p.m. Beijing time. So we our tutorial will have two parts. First part is about 4 hours. It begin from 10 p.m. to 2 a.m. Then tomorrow we will give the last part. So according to the conference requirement, we will record a video and submit it to YouTube. If you don't know the consent to it, please turn off your microphone and camera. AIBench is a joint work with increasing industry partner. Currently, it has about 30 industry partner. AIBench is a comprehensive AIBench project focused on methodology, framework, and continuous improvement. The reason is very simple because the AI model changing ever very fast. So AIBench will systematically tackle for the challenge prohibitive cost. Because it train AI model will take a very long time. For architecture community, it will be much challenging because on simulator, the slowdown will be 100 or 1,000 times. The second challenge is a conflicting requirement in different stages. Meanwhile, the benchmark, the AI model have a short self-life. AI model, it will evolve very fast. Meanwhile, it has scalability challenging because for most of the AI model, it has a fixed problem scale. Another challenge is repeatable challenging due to the stochastic nature of AI. So from this figure, basically, we will introduce the AIBench different component. First, we will model real world of application scenario. It will model critical parts of real world application. We name the scenario benchmark. We'll talk about later. Actually, Edge AIBench is modeling the overall performance of across edge data center and IoT. It's an instance of scenario benchmark. It also includes a training benchmark and inference benchmark. Meanwhile, because we include many different training benchmark, we provide a subset for affordability. For HPC AI benchmarking, because the cost is very heavy. Also, we on the base of AIBench subset, we provide a scalable benchmark tool for evaluating HPC AI system. For end user end device such as smartphone or IoT device, we also implement a lightweight model from the AIBench inference. Meanwhile, for architecture community, because the on simulator is very slow, slowdown very high, so we provide a micro benchmark. Meanwhile, considering the AI model changes very fast, we cannot predict the future AI model. So we provide a synthetic benchmark to model more different AI model. Meanwhile, we also consider how to model dynamic learning dynamics. So this is basically the AIBench methodology. So according to this summary, our tutorial include several different mini talk. In the first hour, I will introduce AI benchmarking challenging AIBench methodology and summary. In the second hour, Mr. Tianshu Hao will talk about AIBench scenario. He will explain how to distinguish real-world application scenario into a scenario benchmark. Mr. Tang Fei will demonstrate how to use AIBench scenario benchmark. In the second part, Mr. Tianru Hao will talk about Edge AIBench. Edge AIBench is a popular Edge AIBench is how to model comprehensive end-to-end edge computing benchmark. Mr. Chuan Xinlan will give hand-on demo on how to use AIBench. From 9:14, Mr. Tang Fei will talk about AIBench training is a subset and is some performance ranking on different AI accelerate. Also, hand-on demo on using AIBench training is also provided. Then in under the first part of tutorial, we have about 35 minutes for discussion. In the tomorrow, the first part, Mr. Zihan Jiang will talk about HPC 500 is a scalable tool for evaluating HPC system. Mr. Lan Chenxin will talk about AIBench inference benchmark. Dr. Luo Qunjie will talk about AIoT bench for benchmark mobile and embedding device intelligence is ranking. So this is basically the schedule for AIBench tutorial. I will talk about the first part. The topic is AI benchmarking challenging AIBench methodology in the summary. The many contributed to AIBench just list some company and some academic institute. More information can be available from their website. For the part, I will talk about the challenging. I think no one will doubt that AI is one of the most important modern computer workload. From IoT to supercomputing, from edge to data center, AI algorithms are widely used in different application scenarios. So I think different from traditional workload, such as desktop workload, web server, modern computer workload have different challenges. First challenge, I think, is how the fragmented application scenario is a marked departure from past. For example, we can find a whole variety of application scenario and modern scenarios. For example, for different application, we have machine perception, machine learning, natural language processing, knowledge implementation, reasoning, automated planning. We also have different AI model. So for AI, for example, for AI chip, I think there are several hundred different AI chip. So that's also why AI benchmarking are urgent. The second challenging for modern computer workload is isolated. I think zero-word data set and workload, or even AI model treated as first-class confidential issue. So they are isolated between academia and industry, or even among different providers. For example, for electronic commands provider, they use different AI model from social network. Okay. So microservice architecture are widely used in industry. They are distributed across different data centers. It often consists of diversity of various modules with very long and complex execution paths. Meanwhile, the tail latency is very important. So under this context, AI are widely used to augment into internet service or other service. So meanwhile, AI benchmark also raises very serious challenges. The first challenge is prohibitive cost. Because the learning dynamic, we have to run an entire training session. Someone may be feel confused why we have to run an entire training session. Because for many optimization, if we do not observe an entire training session, we won't know the optimization will, how about the optimization effect on the quality, the final model quality. Maybe it optimize the throughput, but it will hold the final model quality. So it's why we have to run entire training session. But it will take several weeks to run a complete training session on small scale system. Meanwhile, a simulator, our architecture community widely rely upon simulator. It will slow down times or even 100 times. This which is exactly the challenging. Meanwhile, So a second challenge is a conflicting requirement in different stage. For in the early stage, we need we need the benchmark be affordable because we cannot put many application on to a new architecture or new system. And the late stage evaluation, we need a benchmark are comprehensive and representative because some perfect number using a few benchmark may be misleading. So the third challenge is sort self life. I think the AI model evolution change outpace the AI benchmark. We take 1 year to work through benchmark design, implementation, community adoption, and large scale testing. But the AI model evolve very fast, changing very fast. It may outpace the AI benchmark. Synthetic benchmark like a DNN can traverse many network, but it cannot model learning dynamic. I think the learning dynamic are very important in deep learning. I will explain later. The third challenge is scalability challenging. For example, for most AI tasks, I think a problem scale is often fixed. For example, for HPAI is scalable, but it cannot model the learning dynamic. Meanwhile, it also fails to consider the model quality. For example, for this picture is from HPCA 500 ranking. For ImageNet, using ImageNet dataset and image classification managed. This result for this state art data, the most strong system only need several tens seconds to finish an AI task. So it cannot stress test a large scale system. So we need to consider how to tackle that scalability challenging. The fourth challenge is repeatability challenging. The benchmark mandates being repeatable, especially for system, for benchmarking large scale system. While training deep learning is stochastic. For example, there are many factors of randomness. For example, model acceleration, data argument, data shuffle, dropout, something like that. This picture shows the run-to-run variation of AIBench training. For example, for 3D face recognition, the number of epoch to train a state-of-the-art quality, the variation is about 35%. I think it's very large. For example, the epoch to achieve target quality varies significantly on different random sets. For example, run image to text from AIBench training 4 times using different random sets. We can see the epoch to quality change very differently. So we want to talk about the related work. I think for AI benchmark, the first one is the fashion. It includes 8 workload, provide training the inference benchmark, but it does not use quality metric. Then DNMark provide 8 micro benchmark, but it cannot provide the component benchmark. Baidu provide a DiffBench. It provides AI basic operator containing GMM, convolution, recurrent layer, and all reduce. It only has micro benchmark. DownBench is the first benchmark using time to accuracy as a metric. I think so-called end-to-end AI benchmarking. Then the TPD suite, it provides 8 workload from 6 domains. Our benchmark AIBench, the first paper appeared at Bench 2018. It proposes scenario benchmark. Scenario benchmark means it model critical paths of real-world application scenario. It includes 19 tasks, AI tasks, provide 19 workload. Meanwhile, it also provides subset. Meanwhile, another concurrent work is MLPerf. It provides 7 workloads from 5 domains. HPC AI benchmarking, I think the first one is AIBench. AIBench provides image clarification, the question answer, it performs large-scale testing. It's the first AI benchmark that uses AI time to accuracy as a metric. HPC AI 500 is from our group. It is the first paper. The first paper appeared at Bench 2018. It covers 3 representative applications of scientific deep learning. It also provides hierarchy benchmarking methodology using valid flops as a metric. Deep 500 is another HPC benchmarking. It is published at IPDBS 2019. It provides HPC AI benchmarking framework, but it provides no concrete reference implementation. HPC AI is proposed by Professor Jake Dangra. It's a micro benchmark based on AU decomposition. It's scalable, but cannot reflect model quality. MLPOF is also provide currently also provide HPC AI benchmarking. Another one related was AI benchmark for edge computing. I think Edge AI Bench is the first one AI benchmark about how to model AI scenario across an IoT edge in the data center. It provides 4 application scenario: ICU, patient monitoring, camera monitoring, smart home, automatic driving. It also integrated federated learning. AIBench is from UCC companion. It also provides speech recognition, image classification. Another Edge AI benchmarking is from EMBC. Meanwhile, there are also IoT AI benchmarking. The first one is from ETH. ETH have provide AI benchmark, also provide AI benchmarking ranking. It is reported many number. We also provide AIoT bench. It supports Android and another IoT device. It provides several AI framework implementation, for example, TensorFlow Lite, KV2. I give a very simple summary of the related work. AIBench is the first benchmark that proposes time to accuracy as the main metric. AIBench is the first benchmark that notes the necessity of modeling the created parts of a real-world application scenario. ParaDNN from Harvard University is the first synthetic AI benchmark. The HPC AI is a micro benchmark that uses mixed precision AU decomposition to achieve outbound flaws performance. HPC AI is a micro benchmark, is scalable, but AU decomposition is not relevant to most of AI workload. Both ParaDNN and HPC AI cannot model learning dynamic, also fail to consider the model quality. So in this section, we talk about AIBench methodology. Could you hear me?
Yes.
Okay, let's continue on. AIBench from International Open Benchmark Council is a non-profit international organization aimed to promote the standardization, benchmark evaluation, incubation, and promotion of PC, cheap AI, big data. The project homepage is part of it from this website. Overall, it provides scenario benchmark. It models creative parts of real-world application scenario. Edge AI Bench is an instance of AIBench scenario benchmark. It also provides AI training benchmark. As we include 19 AI workload, so for affordability, we also provide AIBench subset. For HPC AI system, because the benchmark cost is very heavy because you have to perform testing on very large scale system. So we also provide HPC AI 500 benchmark on the basis of AIBench subset. Meanwhile, we provide AIBench inference. I think different from MLPOF inference for our AIBench inference include many different AI model. The reason is very simple, because for inference workload, the overhead is very small. So we can include a comprehensive workload. Meanwhile, we provide AIoT-Bench is a lightweight implementation of inference workload on mobile device. Meanwhile, we provide a micro benchmark for architecture community. I think for AI, for architecture community, the training benchmark are too heavy to run. So we provide the AIBench training and AIBench inference workload. We provide a hotspot function for architecture simulator. Meanwhile, we provide a synthetic AI benchmark because AI model changes very fast. So we cannot, currently we develop a new AI chip for AI workload, but someday maybe we provide a new AI model. They have used different hotspot function, different operator. So this situation is we also found that the current AI chip, for example, for AIBench workload, we run on TPU. TPU is a very good AI chip from Google, but we found that TPU cannot support running many AI models. So this situation is very important. So we provide a synthetic AI benchmark. We can model the future AI model. So this summary, we explain our methodology. First, we start the real-world future application scenario. And we separate the real-world application scenario. For many application domain, I think the AI-based application are not developed. So we also consider maybe we can propose some specification for future application scenario. Then we can model the critical path of real-world application scenario as a permutation of AI or non-AI module. Someone maybe just say, oh, why do you include a non-AI module? Actually, in the United States, I think for many applications, they also include AI and non-AI part. Meanwhile, AIBench is then our scenario benchmark suite, modeling end-to-end performance across IoT, edge, in the data center. I think for this scenario, because we can, for the same requirement, if we distribute a different workload, different model on different layer of the system. For example, we can propose a different collaboration policy on different layer. So it will affect the overall system very significantly. So AIBench and AIBench training and AIBench inference cover 90 the preventive AI tasks. We will continue to update. As I mentioned earlier, the AIBench focus on methodology, framework, and a continuous improvement with state-of-the-art model to guarantee diversity and representativeness. Meanwhile, AIBench provided two subsets for the repeatable performance ranking subset and workload curation subset to improve affordability. Meanwhile, to evaluate a large-scale HPC system, HPC 500 derived from the AIBench training repeatable performance ranking subset. I emphasize the repeatable because for HPC system, if benchmark have very high readiness, it cannot accurately measure a system. So we must guarantee the subset chosen from full AI bench training workload, the chosen workload are repeatable. To evaluate various IoT and embedded device, AIoT-Bench is derived from AIBench inference. It provides a lightweight model on different lightweight framework. Meanwhile, AIBench micro provider intensively use the hotspot function provided from AIBench training inference for simulation-based architecture research. As a complementary to real-world benchmark, AIBench synthetic provides several synthetic benchmark with scalable problem size while model learning dynamic. As I mentioned earlier, most AI model, its problem size are fixed. So we use synthetic benchmark to provide a scalable benchmark tool. Meanwhile, we model learning dynamic. So this is the AIBench methodology. Sorry, we have a little puppy. It will make noise. So the first question is the micro benchmark sufficient. AI workload need to consider both computation efficiency and model quality. Flops no longer the only metric. For example, mixed precision training significantly improve flops. However, it may deteriorate the model quality. For example, from this figure, we can see flops comparison with ResNet 550 model, the mixed precision optimization can significantly speed up the micro benchmark. But if we take a look at the performance of component benchmark like ResNet 15, we can see the optimization will decrease the target quality. Meanwhile, for example, for HPA AI, it just using a single kernel to model to reflect the benchmark, but it's not the case for AI benchmark because, for example, we provide a 17 AI workload from AIBench. We found that some micro benchmark may occupy a little percentage. There are many different diversity of micro benchmarks. So which one we should choose? Another question is component benchmark sufficient to evaluate the AI system. For example, we benchmark with single component named image to text is OCR. We can use some OCR model pruning optimization. It can shorten tail latency by 51%. Meanwhile, the accuracy loss is only 1%. Someone may say, oh, this is good result. But if we take a look at put the component of the elastic scenario, we consider the overall system performance. We can find, for example, image to text is a small part of this scenario benchmark. We can find, we use a thin OCR model pruning. We can find tail length have no improvement because the image to text take a very small percentage of overall performance, while the accuracy loss is also kept the same, is 1%. So for the second case, we can conclude that the optimization does not work. So using component benchmark alone will lead to misleading conclusion. Meanwhile, we found the single component versus electric application. For example, for electronic command search intelligence, the overall system tail latency deteriorated even 100 times compared to single component tail latency. For different component, the number is different. For example, so for the recommendation component, the number is 2.2 times, while for text clarification component, the number is large as 180. Meanwhile, we also need trade-off model accuracy versus quality of service. For example, for electronic command search intelligence, we replace ResNet 50 with ResNet 152. You have multi-layer for implication clarification. Model accuracy improvement is about 1.5%, but the latency deteriorated by 90.790. So benchmarking a single component cannot reflect the trade-off between model accuracy and QoS. We have to put in put the benchmark into a full application scenario. Meanwhile, someone may just ask, does the static model predict the overall system latency so providing many component latency problems? The answer is no. With two different models, for example, simple queuing model, Soviet queuing network model, we found that we cannot model the zero application scenario. So we have to use zero scenario benchmark. So a scenario benchmark is a process of zero elastic application scenario. It captures the created path and the primary module is the formulation of a series of AI and non-AI components. This is a scenario benchmark. It counts search intelligence, include a query generated online module, offline module, data storage model. You can read the technical report from a project homepage. AIBench is an instance of a scenario benchmark suite. It modeling end-to-end performance across IoT edge and data center. The project homepage is this one. We also have to have a paper. Currently, it provides 4 typical edge AI scenario. Autonomy vehicle, it focuses on latency sensitive, high accuracy in the mobile scenario. Another one is ICU patient monitor. It's latency sensitive. Also provides surveillance camera. It includes aminos data, very large number data. It also provides smart home scenario. It includes heterogeneous device and data. This is the basic summary of the edge AI task. I think that Tianxu will provide much more detail in the later talk. I just give a very short summary because time is also very limited. We have used 48 minutes. Another one is AI training. AI training consider conflicting benchmark requirements in different stages. For example, I just mentioned earlier. So we consider diverse behavior for workload creation, include micro-architecture level, such as flops, memory access pattern, compute pattern, I/O pattern. System level include iteration time cost, variation, convergence rate, for example, how many epochs to train or state out quality, number of host function. Also, we provide algorithm level, include model architecture and parameters. AIBench training include 19 workload. We have a part is part paper. You can find more detail from that paper. For example, take econs as example. We have image classification, object detection, spatial transform, translation, recommendation, learning to rank, speed recognition, image compress from different applications. We just provide this component benchmark. In this figure, we compare AIBench training versus the MPOW training within 0.7. Basically, we provide a balanced methodology, consider conflicting requirement. We provide 19 tasks in the model. We provide different data set. We cover much wide space in terms of computation, complexity, optimizer category, loss function category, hotspot function, different convergence rate. So I think there are different requirements for example, for performance ranking, we have to consider that fairness, it must be repeatable. Also, the cost must be very low. Meanwhile, for workload correlation, the repeatable maybe are not very important. Because, for example, for GAN, workload there is repeatability is very low, but it is a very important workload. So we also have to consider workload correlation. So we use some class algorithm. We have finalized 2 subsets for different purposes. One is for repeatable performance ranking. Another one is for workload correlation. Tangfei will talk about more detail in the later. HPC 500, I think, is based on AIBench training subset, because it's impossible for run 19 AI workload on large-scale HPC systems. So we just based on AIBench training subset. Meanwhile, for HPC AI 500, we must consider the workload must be repeatable. So we remove the unrepeatable workload. Currently, we include two workloads for HPC AI 500. One is the image classification. Actually, it's a de facto HPC AI benchmark. Many groups using this workload to evaluate large-scale systems. Meanwhile, also include object detection. We provide two problem domains. One is extremely weather analysis. It is use object detection algorithm. Another one is image classification. I will talk about AIBench inference. I think for AI inference workload, comprehensive workload are not important because it will take a very short time, for example, several seconds to finish inference workload. So that the overhead is very low. We can include a much comprehensive workload as possible. So we include diversity with data type, AI mode, AI framework. We also consider diversity workload behavior from algorithm system architecture perspective. Currently, it includes 19 workload. For example, coverage diverse network architecture, CNN, ZSNet, STN, GRU, attention, and something like that. We provide text processing, image processing, audio processing, video processing, and the 3D data processing. The last one is AIoTBench. AIoTBench actually is implementation on mobile device or IoT device. It is the purpose is to evaluate the end device. AIoTBench covers representative and diverse model and framework. It provides a heavyweight model, lightweight model. It also provides a different implementation on different framework on TensorFlow Lite, KV2, PyTorch mobile. AIoTBench can be used for comparison of different AI model, different AI framework. Also, ranking AI ability of different mobile device. Actually, the different AI model architecture are designed with very different philosophy. Is widely used in the architecture industry. So we need to consider different AI model. The last one is a micro benchmark. Benchmark is the purpose is to tackle the prohibitive cost challenge, especially for architecture community, because on simulator basically it's impossible to run a training workload on a simulator. Meanwhile, it have to be easily portable across different architecture. Micro benchmark are much easier. Meanwhile, we provide a basic AI operator and we use hotspot code function from both AIBench training and AIBench inference. This combination of AIBench micro benchmark from deep bench micro benchmark, we think we provide a much more operator or code function. Meanwhile, also provide different data input. For example, for metric, we provide dense metric, dense spare metrics with a different size. The last one is synthetic benchmark. Synthetic benchmark to tackle the short shelf life and the scalable challenging. So we provide as a representative building block from AIBench training. We also provide different depth, width, and input size, different stride and pattern size. We also we also train the generative model to convergence to reflect learning dynamic, which paradigm cannot reflect. So we give a very short conclusion. AIBench design and abstract real-world application scenario called data science, HPC, IoT, and edge into the scenario training, inference, micro, and synthetic benchmark. This is a project homepage. So in the rest part, we have another 7 hours for our tutorial. 听如好 will talk about AIBench scenario and Edge AIBench. Tangfei will talk about AIBench training subset. And Jihanjiang will talk about HPC 500. 川西南 will talk about AIBench inference benchmark. 陈杰 Law will talk about AIoT bench. Tangfei, sorry, because our network are poor, wasted a lot of time. I apologize again. So I transfer the control to Tangfei. I think the next speaker is Tiansu Hao. Thank you very much.